The traditional approach to the development of a new product generation is to use established parts and components, which are adapted according to new requirements. Due to time pressure, engineers have little scope to develop different designs and solution options. This is because evaluation, manufacturability, testing, and validation is very time-consuming and are therefore costly. Furthermore, engineers often do not have the comprehensive knowledge of the different materials and manufacturing processes to really do an overall design exploration. But what if engineers no longer had to consider the explicit design and geometric shape, but rather defined the boundary conditions relevant for a particular design solution and then compared and evaluated different design variants against each other? Detached from past solutions and thus really free and open to the whole design space? This is where generative design and the use of artificial intelligence come in. In contrast to topology optimization, which starts with a given part geometry that is then reduced to the minimum lightweight geometry for material savings, generative design requires no predefined shape. Using this method, the forces and loads that will occur and the attachment points, geometries to be retained, are defined, and additional obstacle geometries can be specified as boundary conditions to create a part geometry from scratch. Engineering processes does not necessarily have to be left to a black box style AI. Rather, product development tasks can be completely formalized and modeled through design automation. Today's software tools offer low-code programming capabilities to interface with established CAD and CX tools of the company, which continue to work as authoring tools in the background. By variation of parameters in the process flow, new design variants and solution alternatives can be quickly generated and validated. But how can such tools be used in today's engineering processes? What background do today's engineers need to understand? Are the tasks of engineering design changing? How is the product development methodology changing? These are precisely the questions addressed by the iGita project, Skill Development in AI-Driven Generative Engineering and Design Automation. For the iGita project, experts from different fields work together to explain the theoretical background of generative engineering. These experts combine the background of artificial intelligence and simulation with innovation and product development. Therefore, they create a unified workshop format consisting of interactive learning nuggets, tutorial videos, and hybrid workshops to teach the new methodology and software tools at different levels of experience. Participants learn about the benefits and possibilities, supported by many application examples to better understand the approach. Join our comprehensive skill development program and discover the essential skills, methodologies, and tools required for algorithmic and AI-enabled generative engineering and design, as well as design automation. Learn more about the combination of artificial intelligence, simulation with innovation, and product development. In up to 3 different e-learning courses, you will learn about the theoretical background of generative engineering as a new methodology, benefits, and possibilities, supported by practical application to gain hands-on experience. This interactive e-learning content is divided into 3 learning paths. Generative engineering and design. Dive deep into this new methodology, their streams, benefits, and possibilities. Topology optimization and lightweight design. Understand how lightweight design is built up and acquire the skills how generative engineering sets the next step for it. Generative engineering and innovation. Learn more about the innovation and product development process and gain knowledge about how generative engineering can support and change this. Unlock the future of product development with algorithmic and AI-enabled solution generation.